The purpose of any graph is to visually model the relationship between quantities. In this graph, we're modeling how much mass gets diminished as a result of radiating a certain amount of energy from any object. We've shown mass along the y-axis because mass diminishes as a result of energy emitted. Mass is the dependent variable, or the output in this scenario. And we've also placed energy along the x-axis because we're treating it as the independent variable, or the input. We labeled both the x-axis and the y-axis, and we gave the graph a title, a descriptive title, mass versus energy. The origin of the graph has coordinates 0, 0. The origin, in our case, models an object that didn't lose any mass because no radiation occurred. Every other point in this graph models some amount of mass being lost as a result of some energy being radiated. Now, I'll have the y-axis range from 0 grams to 1 gram. And I'll make the domain in the x-axis go from 0 joules all the way to 10 to the power of 14 joules. According to Einstein's theory, 10 to the power of 14 joules is approximately how much energy an object would need to radiate before losing a full gram of mass. That's why I chose those values for the maximums. To help with plotting points on this graph, I've also placed some scale marks, some little ticks along the axes. It's good to show the intervals between the minimum values and the maximum values of the mass and the energy on the graph. This is called the scale of the graph, and it should stay consistent. I divided the axes, both of them, into 10 intervals, and that means that the scale in the y-axis is 1/10 of a gram, or 0.1 grams, and the scale in the x-axis is 10 to the power of 13 joules. That means in the middle we have 5 times 10 to the power of 13 joules, and we have 0.5 grams in the middle of the y-axis. Ta-da! We have finished setting up this graph, and we can use it to model the relationship between mass and energy in a visual way. Next, we need to find a mathematical expression that we can use to describe that same relationship in terms of relevant numbers and quantities.